This is Physics 2212, Lab 1, Charge Tape. In this lab report, I will first introduce the experiment and then explain the computational model. I will then follow with the results, discussion, and the conclusion. The first purpose of this lab was to prepare charge tapes and investigate their interactions with each other, other neutral objects, and other charged objects. The other purposes of this lab were to determine the force of one charged tape on the other, the number of electrons on one of the pieces of charged tape, and the ratio of excess or deficient electrons to total atoms. The fundamental principles include Coulomb's law and the force of gravity. Coulomb's law is shown on the slide and the value for Coulomb's constant is on the right. The r vector represents the vector from the source to the observation location. The force of gravity is the downward force exerted by the Earth, and it is negative mgy hat, where m is the mass of the object and g is a constant equaling 9.8 meters per second squared. A preview of the result of this lab is the charge tape is positive with a charge of 1.38 times 10 to the negative 8 coulombs. The magnitude of the gravitational and electric force is 1.91 times 10 to the negative 3 newtons, and the ratio of deficient electrons to total atoms is 8.64 times 10 to the 10 is to 9.56 times 10 to the 17, or 1 electron to 1.11 times 10 to the 7 atoms. The experiment information is presented on the slide. The separation distance is 3 centimeters. The length of tape A and B is 19.5 centimeters. The width of tape A and tape B is 4.9 centimeters. And the mass of tape B is 1.95 times 10 to the negative 4 kg. The system is tape B and the surroundings are tape A, the Earth, and everything else. The key assumptions of this experiment is the tape is assumed to act as a point charge where all of its charge is localized at the center of the tape. Also, both the tapes have the same net charge. The overview of the procedure is to stick a base tape on a desk and create U-tapes by smoothing on top of the base tape and quickly pulling away. Second is to observe the interactions with other tapes and objects, and the last is to place one U-tape between two stacked objects and place other U-tape below to make tape B hover as it is repelled. The observations of the experiment are as follows. Two U-tapes repel each other, indicating that they have the same charge. U-tapes are attracted to neutral objects and a plastic pen that was rubbed against clothing to make it negatively charged. Thus, the tapes are positively charged. Here is the code used in the computational model. The constants are presented as well as lines of code for the calculated results of this lab. The constants include 1/4 pi epsilon 0, the charge of an electron, g, the tape length, the tape surface area, the tape mass, the separation distance, and the atom length. The Python function used to calculate the charge of one of the pieces of tape is shown in the bottom left. It uses Coulomb's law with the assumption that both tapes have equal charges with charge localized at the center. To the top right are the forces of gravity and the electric force. Because tape B is suspended and has a constant momentum, its net force is 0. The vertical forces are gravity and the electric force from tape A. Thus, both forces must be equal to each other in magnitude except for opposing directions, as seen in the free body diagram to the right. Lastly, the number of deficient electrons, in this case deficient because the tapes are positively charged, is the charge divided by the fundamental charge. The ratio is then calculated by dividing the deficient electrons by the total atoms, or the reciprocal for a ratio of one electron to some number of atoms. Lastly, for the results, discussion, and conclusion. The tape is positively charged, so there is an electron deficiency. The charge of the tape is 1.38 times 10 to the negative 8 coulombs. The remaining results have already been mentioned in the introduction and throughout this lab report. As for the sources of error in this experiment, inaccurate measurements of the tape length and width, and importantly, the separation distance. The U-tape was also likely not held parallel, leading to varying separation distances along the length of the tape, but this source of error is mitigated by our focus on the center of the tape rather than its length. Lastly, the assumptions made in this experiment inevitably cause error in the calculated values because they are simplified. Lastly, for the additional questions, what if electrons had a positive charge and protons had a negative charge? The observations would not change if electrons and protons switched charges because that is a change of convention that doesn't affect the real-world interactions that we observed in this experiment. Why is it important to handle the charged tapes as little as possible? Touching the charged tapes will remove the charge because excess electrons will either transfer away or deficient electrons will gain electrons from the object that they are in contact with. Thank you.